Hello viewers, I am Kausalya. Today we are going to see expressions for time domain specifications. So there are basically delay time, rise time, peak time and peak overshoot, that is 4 types. Now we are going to discuss about rise time. So the response of a second order system for an underdamped case. So what is an underdamped case? This is a system whose value of zeta lies between 0 and 1. What is meant by zeta? Zeta is nothing but damping ratio. That is, it is the ratio that tells when the system will settle down. So this is a typical representation of the response of a second order system for underdamped case. So what is meant by rise time here? It is defined as the time taken by the response to reach the cent% value. That is the maximum expected value for a system to settle down. So that is the time taken by the response. You can see from this graph, that is the time taken by the response to reach the peak value. So here what is the peak value? The expected value is to be 1 here. So the time taken by the response to reach this value is known as your rise time. Right. So here this is your expression, and from this expression now we are going to find what is the value for your rise time. So now replace the value, that is replace T by TR in this equation. So the above expression will get modified as, that is C of T will become C of TR, and here 1 minus, in this exponential term there is a T, so that will become TR, and finally here there is a T and this T will become TR, right? So look at this graph carefully. As we all know, an underdamped case is one which will oscillate and finally it will settle down. Okay, it will have some oscillations and finally it will settle down, right? So here when the value of T is TR, that is at T equal to TR, the value of C of TR is 1, right? So now here in this equation, replace this C of TR by 1. Then the next step is, when you move this one to the left hand side, that is this plus 1 will become minus 1 here. So 1 minus 1, which is equal to, the remaining terms here remains as such. And the next thing is, here 1 minus 1 becomes 0 and this right hand side terms remains as such. Now observe carefully, here you see we are having two terms, right? That is, this is your first term and this is your second term. So that is, this forms your first term and this forms your second term. Here these two terms are in multiplication, right? So here the final value, that is the answer is 0. So what it means? Either in these two terms any one term should be 0 or both the terms can be 0, right? But as we all know, the exponential term will never equal to 0. So this term, that is our first term, is not equal to 0. Then what is our next choice? We have to, the only option is this second term is equal to 0. So this is our only option. We have to equate this second term to 0. So here when you equate this second term to 0, so this term is replaced by pi. That is, sin pi is equal to 0. So when the value of, at what value of pi this expression will be made equal to 0, this thing we can take from the sine wave. So this is a typical sine wave. Okay, this is one complete cycle. So in this cycle, you see, when the value of the sine wave becomes 0, it becomes 0 at initial point, it is 0. Then after completing a cycle, it becomes 0. That is, at pi, it becomes 0. Similarly, when you consider another cycle, you see, another cycle will be like this, right? So here 0 pi and here this will be equal to 2 pi. So this equation will be, that is, the value of pi will be initially, when the value of pi is substituted as 0, this expression becomes 0. When you substitute the value of pi as this pi, again the equation becomes 0. Again when you substitute the value of this pi as 2 pi, this equation will become 0. Right. So now whenever the value of pi is equal to 0, pi, 2 pi, etc., this equation becomes 0. So here, now what is the value of pi? Pi is nothing but omega d tr plus theta. So just equate omega d tr plus theta is equal to pi. And omega d tr is equal to, just move this theta to the right hand side. So plus theta will become minus theta. And finally, we can find the value of rise time as tr is equal to, here just move this omega d to the denominator part. So we will be having pi minus theta by omega d. Right. So next I am going to substitute the values of theta and omega d. So to find theta, we all know this is our respective triangle, and from this triangle we are calculating tan theta. What is the value of tan theta? Tan theta is nothing but opposite side by adjacent side, right? So here what is your opposite side? Opposite side is root of 1 minus zeta square and adjacent side is zeta. So here tan theta is given by this expression. We need only theta here. So when you need theta, just move this tan to the right hand side. So that will become tan inverse of root of 1 minus zeta squared by zeta. And this omega d value we already know, it is nothing but omega n into root of 1 minus zeta square. So now just substitute the values of theta and omega d in this equation. So when you substitute, we get our final expression here, and theta is measured in radians. Right. That's all. The derivation gets over here. Hope you people understand. Thank you.